Hello everyone, my name is Diksha and I am from the Bodhi Academy. Today I want to continue with the chapter that is P block elements from 12th standard chemistry, and I'm going to start with sulfur allotropic forms. So we have in sulfur two allotropes, rhombic sulfur and monoclinic sulfur. So rhombic sulfur is called as alpha sulfur, monoclinic is called as beta sulfur. Now you can see the structures of rhombic and rhombic sulfur. So this is a structure of S8 in rhombic sulfur and this is S6. So we can see that this is a having 8 sulfur atoms, okay, and it is arranged in a crown form. So simple, if you want to understand the structure, what you can do, you can draw this structure W, okay, draw this way. Then you can draw each S atom on the edges here, S. So this becomes your rhombic sulfur having S8. If it is S6, no, then it is chair form. So chair form we show this way, and each here we can draw S. So rhombic sulfur, which is alpha sulfur, only need to know the name and what it is called as, alpha or beta. Monoclinic is called as beta sulfur, and these are the structure which are given, S6 and S8, which you need to know. Then about sulfur dioxide. Sulfur dioxide is SO2, which can be prepared by you taking sulfur with dioxygen to give sulfur dioxide. Also sulfur trioxide, when treated with hydrogen ion or acid, we get sulfur dioxide, okay. These are the method to prepare sulfur dioxide. Then next is it is produced industrially by as a byproduct of roasting of sulfide ore. So this sulfide ore is taken, ferric, and treated with oxygen to give oxide and SO, sulfur dioxide. Then sulfur dioxide, when treated with chlorine, gives sulfur dioxide chloride, and it is oxidized to sulfur trioxide by oxygen in the presence of vanadium oxide catalyst. So V2O5 we can use to produce sulfur trioxide. Then about oxoacids of sulfur. Oxoacids of sulfur, like how we have seen hypophosphorus acid, okay, phosphorus, oxoacids of phosphorus, similar way of sulfur we have sulfurous acid, sulfuric acid, peroxo disulfuric and pyrosulfuric acid, which is a oleum. Now these structures are very important as they are asked in the exam, and their formula: sulfurous acid having 2 OH ions, sulfuric acid having 2 OH ions, and so on. So let us start with sulfuric acid. It is the most important industrial chemicals worldwide, okay, and is prepared commercially by contact process. Now it involves 3 steps. First step is burning of sulfur or sulfide ores in the air to generate SO2. So this is the step in which we generate SO2. Second step, conversion of that sulfur dioxide to sulfur trioxide by the reaction with oxygen in presence of catalyst V2O5. So this is the second step. And third step is absorption of sulfur dioxide in sulfuric acid to give oleum. So this is the last step to give oleum, okay, and this is the method which is shown how to prepare the sulfuric acid. So sulfur and air, that is O2, they are taken, then it's impure, so treated with dust precipitator, then further goes in the washing and cooling tower, and water spray is put, then waste water is removed through that, and whatever is important is passed to the next chamber, which is concentrated sulfuric acid spray chamber, wherein the spray is done, and then dry SO2 plus O2 is passed in the preheater. Then further it is taken to catalytic converter, in which V2O5 catalyst is present, and then finally SO3 is given out to produce the concentrated sulfuric acid. This is one of the important reaction of sulfuric acid, that sulfuric acid removes water from organic compound and its chairing action on the carbohydrate. So sulfuric acid, okay, sulfuric acid can be prepared, it can be reacted with glucose to give carbon and water. So it reacts with glucose to give this, and sulfuric acid is having low volatility. It's a dehydrating agent, and many wet gases can be dried through sulfuric acid. It removes water from organic compounds. So this is a sucrose. Sucrose, when treated with sulfuric acid, gives carbon and water. And then both the metals and non-metals are oxidized by concentrated sulfuric acid. So these reactions are also equally important. Copper is, when treated with concentrated sulfuric acid, gives copper sulfate, sulfur dioxide and water. When sulfur is treated with concentrated sulfuric acid, gives sulfur dioxide, water. And carbon, when treated with sulfuric acid, gives carbon dioxide, sulfur dioxide and water. Then about group 17 elements, which all are halogens: fluorine, chlorine, bromine, iodine, acetylene and tennessine, wherein only 4 are important. Now we have been studying halogens from last 2 years. Halogens are the second elements from second last group of P block. So fluorine and chlorine, they are abundant, while bromine and iodine are less. So that's why fluorine and chlorine are mostly used in most of the reaction. So this is fluorine, then chlorine, bromine, iodine. These 4 are very important elements. Talking about their configuration, they are having NH2NP5 configuration. Then atomic radii, halogens have smallest atomic radii in with respective periods due to the maximum effective nuclear charge. Then atomic radius of fluorine, like other elements of second period, is small, and atomic and ionic radius increase from fluorine to iodine due to increasing number of the shells. Also ionization enthalpy follows the same trend like all other groups. So they have little tendency to lose electron, because they have maximum electron gain enthalpy. So they have less tendency to lose electron. They have very high ionization enthalpy, meaning if you have to remove the electron, you need to give more energy. Then electron gain enthalpy, they have very high maximum electron gain enthalpy, and this is due to the fact that they have only 1 electron less for this stable configuration. Electronegativity decreases down the group. Fluorine is the most electronegative element in the periodic table. Then talking about their physical properties, they fluorine and chlorine, basically they are gases. Bromine is a liquid and iodine is a solid. Then their colors, fluorine is yellow, chlorine greenish yellow, bromine red, and iodine is violet in color. And they show reactivity, bond dissociation enthalpy from chlorine. Chlorine is having more bond dissociation enthalpy than bromine, than iodine. But fluorine is showing anomalous behavior here due to the electron-electron repulsion among the pairs of fluorine molecule. Then about oxidation states, they exhibit -1 oxidation state, and in some compounds they may exhibit +1, +3, +5 and +7 oxidation states. Then next is very important anomalous behavior of fluorine. Like other elements of P block in the second period, fluorine is anomalous in many properties. So if you talk about ionization enthalpy is very high in case of fluorine. Electronegativity and electrode potential, they are higher in the fluorine than expected. Also ionic atomic covalent radii and melting and boiling point enthalpy of bond dissociation are lower than expected. So this anomalous behavior of fluorine is due to, first of all, small size, high electronegativity, low fluorine-fluorine bond dissociation enthalpy, and non-availability of d orbitals in the valence shell. So these are the important reasons for its anomalous behavior. Then next, reactivity towards hydrogen. So hydrogen halides. First of all, the acidic strength, it follows the same order as we have seen in the previous groups. Acidic strength increases down the group, then stability decreases down the group, and bond dissociation enthalpy decreases down the group. As you go down the group, you can easily break the bond of the lower halides. Then oxygen, reactivity towards oxygen. Halogens form many oxides with oxygen, but most of them are unstable. So fluorine forms two oxides, OF2 and O2F2, where OF2, oxygen difluoride, is thermally stable at 298 Kelvin. Then chlorine oxides, we can see Cl2O, ClO2, Cl2O6 and Cl2O7, highly reactive oxidizing agents and tend to explode. ClO2 is used as a bleaching agent for paper pulp and textiles in the water treatment. Then reactivity towards metal, magnesium plus bromide. Bromide is the halogen halide which is treated with magnesium metal to give magnesium bromide. Then ionic character decreases in the order. So ionic character of the halides is more, you can see, in fluorine, then chlorine, bromine, and then iodine. So then reactivity of halogens towards the halogens, that means they can form interhalogen compounds, which we will see as a separate part. And then about chlorine, its preparation, this is very important, and yeah, this is frequently asked, Decon's process. So it is prepared firstly by heating manganese dioxide with concentrated HCl. So MnO2 plus HCl gives manganese dichloride plus chlorine. However, mixture of common salt and sulfuric acid is used in the place of hydrochloride. So sodium chloride plus manganese dioxide and sulfuric acid gives manganese dichloride, sodium hydrogen sulfate, water, and chlorine. Then very important method to produce this is Decon's process, in which HCl is treated with oxygen. HCl, that is hydrogen chloride gas, is treated with oxygen in presence of copper chloride, cuprous chloride catalyst at 723 Kelvin. It gives chlorine and chloride and water. Electrolytic process, this can be done by electrolysis of brine, that is concentrated sodium chloride solution, and chlorine is liberated at anode, and it is a byproduct of many chemical industries. Then next we will see about HCl, hydrogen chloride. Hydrogen chloride can be prepared by heating NaCl with sulfuric acid, sodium chloride with sulfuric acid, sodium hydrogen sulfate with sodium chloride, to give this particular product. Then HCl gas can be dried by passing through concentrated sulfuric acid. Then oxoacids of halogen. So yeah, these structures are equally important like previous structure, which hypofluorous, hypochlorous, hypobromous, and hypoiodous acid. Then halic acid, 5, these are given. And interhalogen compounds mean the compounds which are formed by two different halogens. So in this table they have shown, in this type we have 1, 2, 3, 4, 5 types. ClF, okay, chlorofluoride, bromofluoride, iodofluoride, bromochloride, these are the compounds and their characteristics. Now these compounds, they are given with the structures. So ClF3, chloro trifluoride, it is having bend shape. So almost all are having bend shape, that you can remember in this form. Then this form, they are having square pyramidal shape, XX5, that is IF5, BRF5, and XX7 they are having pentagonal bipyramidal. Then one more question is asked about this is interhalogen compounds. Uh, yeah. So the chemical reaction can be compared with individual halogen. That means interhalogen compounds are more reactive than halogens. This question is asked. Now the reason is because interhalogen, that means XX, two different X, that is two different halogen bond in interhalogens is weaker than two same halogen bond in halogens, except for fluorine. This is the anomalous behavior. So all these undergo hydrolysis, giving halide ions derived from the smaller halogen and a hypohalite, halite and perhalate, and anion derived from the larger halogen. Then next is group 18 elements, which is having noble gases. Okay, so helium, neon, argon, krypton, xenon, radon, these are the examples here. So occurrence, they occur in the atmosphere, in the dry air around 1% by volume. Okay, and radon is obtained as a decay product of 226 radium. So again we can see this table: helium, neon, argon, krypton, xenon, radon. So their configuration is fully filled, that is NH2 NP6. Ionization enthalpy